Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. So let's move on to our different components. What make up a wireless network? So in the lecture, there actually was a video looking at antennas and ports that was outside of our scope. But antennas are what allow us to receive our wireless signals. Here we have a laptop with a wireless NIC. As we defined NICs earlier, a NIC is going to be any type of interface card allowing us access to that type of network. If we need access to a cellular network, we would have a cellular NIC. If we needed a Bluetooth card, that would grant us access to the Bluetooth network. If we wanted to have access to a WiMAX network, we would have to have a WiMAX NIC, and so forth. So what is really interesting is as we start developing more of our wireless technologies, we have to look at what our technology portions are. For the home device, it's going to be a router, it's going to be an access point, and it's going to be a switch all rolled into one. If we're talking business, normally business separates these functions for better functionality. For example, an access point, also known as a WAP, wireless access point, or just an access point, AP. All of these, the purpose of this is actually about being able to take the wireless functionality and attach it to a wired network. So if you have wireless clients, they have to have access to an access point so they can gain access to the wired network. Here we have 2 types of APs. We have an autonomous AP, basically it's standalone and it's configured by itself, or we have a controller-based AP. This is known as a lightweight access point. When we use the lightweight access point, it will communicate with some type of wireless controller. And for Cisco's realm, we are using the wireless LAN controller, WLC. Basically, each controller-based access point will automatically be configured and managed by the wireless controller that's on that network. And actually, that's what we have labs doing, is configuring both an autonomous AP and configuring a WLC-based network. Antennas are not made equal. We have 3 main types of antennas. Omnidirectional, which is basically providing 360-degree coverage. We have directional, and that's more of a focused area. And lastly, we have MIMO. MIMO is multiple input, multiple output based antennas. They will use multiple antenna types to increase bandwidth. So MIMO is more of a technology that the access point will use to allow for multiple antenna or multiple antenna types to allow them all to work together. So moving on, let's talk about wireless operations. Alright, so we have a few videos in our lecture that cover things like BSS or ESS, which we're going to talk about. So our operational modes actually have 3 main types of topologies: ad hoc, infrastructure, or tethering. Tethering is going to be some type of either wired or wireless tethering to like a mobile device, and then using the mobile device to connect to a cellular network to get on the internet, a hotspot for example. Infrastructure mode is actually going to be a managed access point where we have wireless systems connecting to that access point, and that access point connects to the wired network to get our internet. Ad hoc is like more of a peer-to-peer between 2 wireless devices. We have our BSS and our ESS. Our BSS will use a single access point to interconnect all associated wireless clients, where a ESS is a union of 2 or more BSSs. And that way you can have multiple BSSs allowing for that communication. If we're looking at our wireless frame, An 802.3 wired frame is slightly different than a 802.11 frame. 802.11 is wireless, 802.3 is a wired Ethernet frame. With our header, we're going to have things like our frame control duration. We're going to have 3 address types, a sequence, and additional address types. That way we can actually have address, both source, destination, and of the access point. With wireless, we have our carrier sensing media access collision avoidance, CCNA, CA, which is slightly different than our wired version, CCNA, CD, collision detection. With our CA, basically we are in half duplex, and since we cannot hear what other organizations or other devices are using, we're going to just try to listen to the channel. If it's idle, no other traffic is currently on that channel, we will then send a RTS message. Basically, that's a clear to transmit type message, or sorry, ready to send type message. And the access point will request a dedicated access to that network for that channel. The device will get a clear to send CTS message from the access point, granting them the access to send data. It will wait a random amount of time before restarting the process if there is no clear to send message being able to be received. The data will then be transmitted. Acknowledge for all transmissions will be there. If a wireless client does not receive an acknowledgement, it assumes a collision occurred, and then it restarts the process all over again. So how does a wireless device connect with an access point? Normally, there are 3 stages. There is the discovery of a wireless access point through a beacon requests. The access point will authenticate against it. Then there is an associate with that access point. That way, that access point will actually have that MAC address of that device geared towards that access point. As that device goes through the network, for example, if there has to be a handoff between one access point and another, then that association will change. So how do we actually get successful association? We'd be looking at the SSID. That's the name of the network. We'd be looking at the password. That's typically some type of pre-shared key or passphrase used to connect to the network. There is going to be a network mode. That's going to be the appropriate 802.11 standard that will be used. A, B, C, G, N, AC, AX, and so forth. Then the security mode has to match. Are they using WEP? Are they using WPA? Are they using WPA2 personal? And so forth. Lastly, they have to agree on the frequency bands that they'll be using. All of those 5 things have to match in order for the association to begin. So the discovery mode can actually happen in one of 2 ways, passive or active mode. In passive mode, the wireless client will just sit and wait. The access points will actually broadcast beacons with the SID supported standards and security settings. In active mode, the wireless client will send out what SIDs it knows about and what supported standards it knows about, hoping that an access point in range knows about it and allows for the connectivity. This is called probing. The issue is, if a wireless client is the one that is sending out information, the access point, if it is a rogue device or a wireless hacking device, could actually modify its configuration to match the probe coming from the wireless client, and that leads to other security issues. Questions, concerns, please reach out. Thank you.